So to start off with, we're going to start here on 901, and we're going to look at the idea of inheritance. If it's inheritance, it's the same thing with different pronunciations. You can blame my previous instructors who said it the other way. So, not everybody who speaks English is from America. Really, what we're looking at here is the idea of generalization versus specialization. When we first saw the aggregation of classes in chapter 14, what we saw was a means for providing access to a class's functions, a means for providing access to variable members, but we still kept them separate and apart from one another. As a matter of fact, the examples we saw were of completely different things, right? When we talked about creating a class as an aggregation, a class had an instructor and a class had a textbook, and an instructor and a textbook are completely different entities. Here, with inheritance, again, this is starting on 901 and this is 15.1. We have the idea of generalization and specialization. What we are going to be doing is creating abstract classes, things of general use. So the idea here on 901 is an insect and a grasshopper, right? Or an insect, a grasshopper, and a bumblebee. Can you really point at, and we've already seen this with abstract classes, but we're taking it further, can you really point at an insect? No, not really. You're pointing at a grasshopper, you're pointing at a bee, you're pointing at a spider. I think that they are insects technically. You're pointing at a caterpillar, so on and so forth. The idea of an insect is generalized. They have, a number of eyes, they have a number of legs, they have a creepiness factor maybe depending on who you are. My boy, who I hear running around upstairs, hates spiders and ladybugs for some reason. So those would be very high on the charts for that, but loves caterpillars, very low on the charts for creepiness factor. So the idea of inheritance is, let's put number of eyes, number of legs, creepiness factor, things of that nature into the general class, the insect class. And then when we derive from it, for bumblebees, for grasshoppers, for spiders, who I still think are insects, when we derive into them, what happens is the derived class inherits from the base class members. Those members include everything but the constructor and everything but the destructor. So all of the private and public, and we are going to see protected as well in this chapter, all of the private and public members of that class, so the variables and the functions, are extended down to the derived class. So that is the purpose here of inheritance. So we are going to track much more closely the idea of a student, or some student facing examples here. So we will look at grades. If you think about the assignments that you do, they all of them have certain things in common. They all of them have a name. They all of them would have a number of points. So rather than keep defining new classes with names and number of points, we would derive we would create a base class. That base class here in the text is called a graded activity. I will tell you one thing, is when you are in your project teams, when you are in an industry someplace, when you are developing a product that requires a base class, it is often the hardest thing to do is name those, because they are, by necessity, they are abstract. It is difficult to point to something and say this is what it is. So oftentimes you will struggle mightily in naming your your most abstract classes, but that's perfectly okay. So here we have the idea of a graded activity, and this is on page 910. Excuse me. And the graded activity is going to be the topmost on our inheritance, our hierarchy of inheritance. It is going to be from which all other classes are derived. And a graded activity has mutators. They have setters for things like the name of the activity and the number of points in the activity. They also have accessors. We can see right here, it's line number 24. It is get score, and we have a letter grade. So that would be a member function, and get letter grade would be something that is available to any and all classes that derive from graded activity. So here in, this is page also 910, we can see the graded activity.cpp. Remember, in our header file here on line, it's the accessor ones, the char get letter grade. That one is not defined there in your header, so then the responsibility for this is going to overflow into your CPP. And here you can see that we have an if-else chain that helps decide, based on your number score, what your letter grade is. And as we keep going down here, we are going to see it does that. We are going to see a final exam.h, and this is 912. So a final exam is going to be derived from a graded activity because it has a name, and because it has a score, and because it has a get letter grade. We don't have to redefine these here in final exam. So as you can see, we on line number 5 here of the code sample, class final exam : public graded activity. That is creating that bind between our base class and our derived class. That is exactly the same as we would have seen in chapter 14 when we were looking at aggregation, and it's the same we would have seen in 14 when we had friend classes. This is more involved than a friend class. It's not one that simply needs to sometimes gain access to some of the private member functions or variables of the derived class. It actually extends. It is of that same class. Now, it's one of the things we're going to come back and look at. It is a. So in this case, final exam is a graded activity. So that is the relationship. It's called an is-a relationship. So this is the idea of inheritance. We have a base class that contains members that other classes are going to need, that are more specific than our general base class.